Alright, we're on 0654 Summer 18 paper 4.1. This is question 9. Okay, we've got a washing machine connected to a 230 volt supply. Remember that 230 volts means the amplitude of the alternating current that we're using. The washing machine uses 2500 watts of power. When operating, okay. Name the unit with the symbol W. Okay, I hope everyone's got this. That the symbol W refers to watts, spelled W-A-T-T. Okay. We're then asked to calculate a current, I. Alright, so if I was being a bit more thorough, I'd be writing an I here, I'd also be writing a P here, and I'd also be writing a V up at the top here. Okay, we know P, we know V, and we're being asked to calculate I. Again, if you want a triangle, go for it. Hopefully we don't need to rely on these too much. P equals IV, PIV, alright. We need I, cover up the I, you're left with P over V, I equal to P over V. We've got 2500 divided by 230, 10.86, 10.9 amps. The answer scheme, the mark scheme gives you 11. I don't really agree with that. Okay, 10.9 to me is not the same as 11. However, you get away with it in this case. We've got the water inside our washing machine being heated by an electric heater. We need to describe in terms of particles how thermal energy is able to pass through the metal parts. Now, this is where I think we need to be very, very clear. Okay, in any material, I'm going to draw atoms. These are our atoms, and if I heated this end, what this guy does is he starts to move left and right. He starts to shake, okay, or vibrate, to use a far better word. All right. As a result, this one will start to vibrate, and as a result, they'll all start to vibrate and pass from the hot end to the cold end. Okay, that is conduction. All right, it's passed from particle to particle, and it's passed by vibration. Now, in the mark scheme, that's what they were looking for. However, there is a confusion here, I think, thrown in by the word metal, because in metals there's another way of energy transfer which is actually much faster, and that is due to the delocalized electrons. Okay, and what those guys do is electricity. We're setting up an electric current. We heat here. We give the electron, the delocalized electron, energy. It moves from the hot to the cold end. Okay, in the mark scheme they don't mention this at all, and I think that is a bit of a misleading one. I would suggest that you can include both in your answer. Okay, they are passed by vibration, or in metals, it's carried by delocalized electrons. Okay, this is where it's a bit of a red herring, and I think the mark scheme is a bit of a nasty one. If you spend time just talking about delocalized electrons to find that they've talked about vibrations, you might be confused. You're actually right in terms of the science, and you have to remember that when we write these mark schemes, they only give really the best or the most common answers that they've received. It's not always the case that if you've written something that isn't on the mark scheme that you wouldn't get the marks. Alright, big question here, not on our syllabus. Okay, this is about Q equal MC delta T. If you want to have a look at that, feel free to pause the video and have a look. I'm going to move on. Okay, wet clothes are hung out on a line to dry. The water in the clothes is able to evaporate. The water evaporates more quickly on a warm day than on a cold day. Describe and explain why warm conditions increase the rate of evaporation. Whole idea here being we've got to think about our reasons for increasing an evaporation rate. 3 ways: high temperature, large surface area. Okay, you see this when, for example, we spread out a puddle, it will evaporate very, very quickly. All right. And then we've also got the use of wind, okay, a draft. And again, if you hang your clothes out on the line, you will find that if it's a windy day, they will evaporate very, very quickly. The water will evaporate very quickly. Okay, let's think about this thing, about the temperature then. Well, remember, if we've got a liquid, with molecules at different temperatures, okay, then if I've got a high temperature, then more of these guys, if I'll just color them in, have got higher energy. Okay, the higher the energy, the more likely these particles are going to be able to leave the surface of the liquid. Okay, so if I keep on heating up this liquid, it will turn out that almost all of my particles are able to leave because I've given them more energy. Well, as a result, I'm going to lose the liquid more quickly, and therefore the evaporation is going to happen more quickly. What have I written? The higher the temperature, the higher the average energy of the particles. Yeah. As a result, more particles are able to leave the liquid when at high temperature, so evaporation happens faster. Okay, that's all for this question.